Starting with the solid H2O molecules, we see that they are compacted and in a nicely organized pattern. As we zoom in, we see the intramolecular forces and the intermolecular forces. The intramolecular forces are shown in green. These are within the molecule. The bonding forces hold the atoms of a molecule together. This is also a covalent bond, which means it's very strong because they bond over the sharing of electrons. The intermolecular force is shown in blue. The forces occur between the molecules. These are weaker than intramolecular forces. With the little fire, we see that heat is being added into the system. This is endothermic, when heat enters into the system from the surroundings, gained heat. Here, delta H, or enthalpy, is greater than 0. This means it is positive and the system absorbed heat. This happens all the time in an endothermic reaction. As more heat gets added to the solid, it starts to melt and becomes a liquid. In a liquid phase, the molecules start to move around and the heat helps it gain kinetic energy. Remember, kinetic energy is just the energy an object has because of its motion. Here, we see the intramolecular forces were not affected, but the intermolecular forces were loosened because of the kinetic energy. The melting of a solid is called heat of fusion. This appears on the graph as a plateau or a phase change. It's when a substance melts or freezes. The intermolecular forces are loosened, as mentioned earlier. Remember, this is from liquid to solid or solid to liquid. Once we've added enough heat, the liquid molecules now vaporize and are now gas molecules. Since the molecules gain so much kinetic energy, the molecules are constantly moving and the intermolecular forces are now broken. But the intramolecular forces remain the same because a phase change is a physical change, meaning the components of H2O aren't changing. So they stay together throughout the whole process. Here we have heat of vaporization, which is when heat is added to change a liquid into a gas state. Of course, the enthalpy is again positive. Now, as gas condenses into a liquid, it is called heat of condensation. The heat evolved when a vapor changes from a gas to a liquid. Heat needs to be removed, which is an exothermic reaction. Now, the enthalpy would be negative because heat is being removed. Now, we have heat of solidification. This is when a liquid freezes and turns into a solid. Heat is once again removed.